All right, I want to talk more specific about the forces. That I've come up with an expression. They actually have a really long one called mob health angst, but that involves all the forces you would ever use in, say, Physics 251, 252, or Physics 151, 152. Way beyond the scope of this one. So for right now, just simplified it. We're going to add two other letters to this throughout the semester, or throughout the course, but Ftown. Ftown is a mnemonic to help remember what forces. When you're trying to think of what forces are acting on objects, Ftown helps you. So what does Ftown have to do with anything? Well, why Ftown? Well, I needed something that could be remembered easily, and there is no word that really has only those 5 letters. Ftown stands for the 5 basic forces that we're going to deal with for almost this entire class. We've got friction, tension, other, weight, and normal. Ftown, that is basically Ftown. Now, what are these forces? Well, there are certain rules that go along with each of them. First, let's start with friction. Friction, first off, opposes desired relative motion. And that's important. Friction doesn't always oppose the motion of an object from the ground's point of view. It opposes desired relative motion. And the relative is between the two surfaces. And what I mean by that is I've got a bag of Fritos here. And as I move the paper, the Fritos come with it. Well, the friction is actually pulling the Fritos in the direction they're going relative to the ground. Now, if the surface were frictionless, and if I do it quickly, I can overcome that friction. If I pull it quickly, well, the Fritos from the paper's point of view are actually going backwards. And so that is an example of desired relative motion, that the Fritos want to move backwards relative to the paper, so friction is pulling it forwards. All right. It requires contact between two surfaces. You're not going to have friction between surfaces that aren't touching. Friction is always parallel to the surfaces, and the pair, remember we talked about forces coming in pairs, and they always act on different objects. The pair of forces are always parallel to each other. That's important. Well, it's all important. Ft, tension. Tension requires a rope change, something that's stretched. And so generally in a force diagram problem, if you got a rope or a chain, you can bring in tension. The big thing about that is that the pair of forces always point towards each other. And again, they're acting on 2 different objects. So I have 2 different objects here. Get my finger orientation right. 2 different objects here. And so it's basically, tension is trying to keep this, basically pulling the objects tight, stretched towards each other. Other. Other's the catch-all. Now, when you're dealing with other shows up if you're given a problem where the source of the force is, first off, it's when the source of the force is unknown. It's in a problem. I've got a box with a 5 Newton force acting on it. What's causing the 5 Newton force? I don't know. That's other. The pair, this is the only time when if on a force diagram for one of my problems, do a force diagram, if you only do one of the 2, you only write one of the 2 forces in the diagram. Now, there is an opposite force. There's the second part of that pair, which is sort of off-screen, as you will. But we don't know what it's acting on because we don't know what's causing the force. Weight, the W in Ftown. Weight is actually generic for any gravitational force, but weight's the main one that we'll be dealing with up until chapter, I think it's 8, maybe 9. Weight requires a huge mass and another mass. Now, there are gravitational forces between any 2 objects. There's gravitational force in those books behind me and me, but it's so incredibly tiny we can ignore it. So weight is when we can't ignore it, and so it requires a huge mass and another mass. For example, a huge mass like the planet Earth, and then me. The force acting on me is about 210 pounds down. Force acting on the Earth, well, it's 210 pounds up, acting on the Earth. It always points towards the center of mass into the other, so the force acting on me is pointing towards the center of the Earth. The force acting on the Earth is pointing towards the center of mass of me. The forces are always pointing towards each other. When you draw the pair of forces always point towards each other. So I have a force acting down on me, and there's one acting up on the Earth. And then the last one of Ftown is normal force. Normal force requires contact between two surfaces. It's always perpendicular to the surfaces. As a matter of fact, normal is a math term meaning perpendicular. So it's called normal force because it is perpendicular to the surface. Perpendicular, right angle. It is compression force. The pair of forces is always pointing away from each other. Unlike tension and unlike gravitational force, normal force is always pointing away. An example of a normal force is right now I'm sitting on a chair. Why am I not falling onto the floor? Well, the chair is holding me up. Well, that's an object. But the force, there's a force that the chair exerts on me called the normal force. The chair pushes up on me. Force gravity is pulling down on me, so I got a weight acting down, acting on me. I've got a normal force acting up. As long as they're equal, I'm not accelerating. And then I'm also pushing down on the chair with a certain normal force, and I'm pulling up on the Earth, and we'll get into the details of doing force diagrams, but that's the basics of it. That's Ftown. You'll be using that for a good bit of your physics. I still do that when I do force diagrams on my problems. I always go back to the basics. It works. Trust me.